Hello everyone, my name is Ziki Fan, and this is my final project presentation. My final project tries to apply two deep learning methods, VGG and ResNet, and test the influence of their parameters on image recognition. Here are the reference papers for my project and the dataset I used. And in this page, you can see the directory of my presentation. Let's begin at the overall objective and dataset I used. The objective of this project is to apply two deep learning methods to a recognition problem and find the influence of the parameters and the inputs. The dataset I used is a flower images recognition dataset which contains over 4,000 flower pictures from 5 classes. Then let's discuss about two methods. First is VGG, Very Deep Convolutional Network Learning. It was proposed in 2014. Its architecture is similar to previous convolutional neural network, but it suggests that we need to set the filter to be the smallest 3+3, just like the graph on the right. And in this ways, the network can generate more information from data and have more layers to deal with the data, which means the network could consider more features than all previous networks. Next is ResNet, Deep Residual Network Learning, which was proposed in 2016. It tries to solve a Banach gradient problem in previous neural networks like VGG. That is, earlier layers are illegible null as there are too much layers. The architecture is similar to VGG, but it adds some shortcuts from previous layers to the later layers to allow them to exchange the information. And here is the experiment settings for my project. I used the for method with pre-trained models, and I divided the dataset into two parts, one for train and one for test. And the next is the default setting of my experiment. And here are the results for testing accuracy and testing noise over apex for four methods. And from the result, we can find that when using the pre-trained model, the testing accuracy for four methods quickly becomes stable. And besides, we can find that the accuracy for ResNet is higher than the accuracy for the VGGs, which is consistent to the result in the paper. Let's consider the testing noise, and we can find that for 3 of the 4 methods, the testing noise is increasing after the number of epochs is larger than 20, which means that they may become overfitting after several epochs. However, when we consider the layers of the network, we will find that the accuracy of the VGG with 16 layers is larger than the accuracy of the VGG with 19 layers, which is not consistent with the result in the paper. And in my opinion, this is caused by that we only unfreeze the last layer, and the more layers the network has, the more impact the parameters in the pre-trained model will have. And the parameters in the pre-trained model is different from the optimal ones for the dataset we used, which causes the decrease in the accuracy when the layers increase. And in this page, we can find the result of testing accuracy when we modify the images by changing the resizing size, rotating, lighting, flipping, and their combination. And from the result, we can find that the combination of rotating, flipping, and lighting can increase the testing accuracy a little. And I think there are two reasons for this. The first reason is that by modifying the images, the more samples will be generated, which will lead to a higher accuracy in the learning. And for the second reason, I think is that the background of the images we used are usually grassland and the sky. When we change the lighting, the network may be easier to find the position of the flowers in the picture. And then I test the influence of the learning rate. I change the value of the learning rate and find that the default learning rate is an optimal choice for the network. And for the future work of my project, I will try to do these things. Thanks for your watching.